Hello, this is Max Wolf in fall 2015, and I'm going to give a quick review of our tree abstract data type in preparation to do some tree recursive problems from midterm 2. Okay, so what is a tree? Well, a tree is a data structure, a recursive data structure, which has a node and some number of branches. Alright, so these branches can have values in them. And the most important part of our tree is that all of our branches are also trees. So what is a tree? Well, a tree is a node, also called a root or entry, and a list of branches, aka a list of trees. Alright, so in our abstract data type, we have three things we need to keep track of. We need to keep track of our constructor. And in the abstract data type, it is a function called tree, which takes a value and a list of trees. So tree 1, tree 2. And we have two selectors. We've got root, which takes an argument tree and returns the root. And branches, which takes an argument tree and returns a list of subtrees. All right, so let's construct a simple tree. If I wanted to construct the tree 1, 2, 3, I would simply call the constructor tree with the argument 1, and then pass in a list of trees with no arguments for my branches to construct leaf nodes. So a leaf node is a tree with no branches. But in any case, so this is how we construct a leaf with a single value for our root 2. And here's how we construct another leaf. And you'll notice that our branches argument is taking a list of trees. Okay, so this is the single most important property of trees, that all of our branches are also defined to be trees. And you'll see this is really important when we start doing problems that involve recursion. Okay. Right, so excellent. So this is sort of like a basic how I would construct a tree. And now let's start accessing things from the tree. So if I'm in Python and I say root t, I'm going to get out as my return value 1, because that's the root of the tree that we're referring to. And if I say branches t, well, depending on how we've done this, essentially we're going to get a list of our trees, which is tree 1, tree 2, tree 3. This might not get printed out exactly like it is here, but the important thing to know is that no matter what, our call to branches is going to return a list of subtrees. All right. Now, what if I wanted to get the root of the first branch? So if I asked you to get the root of the first branch of t, I could call branches t, which I know returns a list of trees. And if I know that it has more than one root or more than one tree in this list of trees, then I can index into it without worrying about an index error. And this is going to give me the root, or this is going to give me the branch, the first branch. So let's call this B1. And now if I want the root of that, I just have to write root B1, and I'm going to get out as my return value 2. All right, so this is a really basic review of what trees look like in our abstract data type. If you have questions, please post on Piazza or post a comment on YouTube, and we'll make sure we get them answered. The next two videos are going to be doing some basic tree problems to help you get comfortable with leaps of faith around trees and sort of using recursion in our tree data structure. So if you have any questions, post a follow-up. Otherwise, see you at the next video.